I was wondering, could you please tell me what IoT is all about?
Hey, sure, let's get started. So, what is IoT all about? Be it our professional settings or social interactions, the internet has a great impact on our lives. The IoT has the potential to add a new dimension to this internet. This can be achieved by enabling communications with and among smart objects. The vision of IoT is to transform anywhere, anyhow, and anytime to anything, anyone, and any service. The future is indeed exciting. The IoT is described as a worldwide network of interconnected entities. The NIC predicts by 2025, internet nodes may reside in everyday things: food packages, furniture, paper documents, and many more. Indeed, this is going to have a high impact on everyday life and user behavior. The internet of the future is likely to be drastically different from the internet that we use today. Indeed, it's going to have invaluable contributions to the economic development as well.
Let's have a closer look. Many technologies serve as building blocks of IoT. These include wireless sensor networks, RFIDs, cloud services, machine-to-machine interfaces, and many more examples. There are multitude of application domains. These are automotive, healthcare, logistics, environmental monitoring, and many more. Recently, IoT has stepped out of its infancy and is the next revolutionary technology. A variety of enabling technologies have been adapted, which are RFID tags, embedded sensors, actuators. As a result, IoT has progressed on its road to transforming the internet into a fully integrated future internet.
IoT in action. Let me show you a few examples to show the current IoT penetration. Mobile applications using sensory devices to provide a range of dimensions of information to enhance user experience. We are familiar with the prevalence of Bluetooth technology in digital products, be it our mobile phones, navigation systems, and so on. So how does it work? Basically, the Bluetooth devices emit signals with a unique MAC ID. Then you can have Bluetooth sensors within the coverage area that can read these signals. So what can we do with this? We can place different Bluetooth readers at different locations to identify movement of these devices which emit the signals. So value can be added to this data by combining it with data sources such as traffic signals or bus GPS to achieve a wide range of applications. Some of these include vehicle travel time on motorways, identification of critical intersections, accurate and reliable real-time transport network state.
That sounds exciting. So, can I put RFID tags in my elder brother's favorite shirt? That way I will know about his whereabouts.
Wait, hold it right there. This is exactly the kind of concerns people have currently in regards to acceptance of IoT. Let me explain.
Let's define what privacy, safety, and security actually are. So privacy is basically control over one's personal information. It is free from the eye of the public. Safety is synonymous to protection. It is the freedom from danger or risk on injury resulting from recognized but potentially hazardous events. Security, on the other hand, is regulating access to electronic assets according to some set policies. It is important to note that these set policies for security are in fact a result of privacy and safety, so all three are intertwined.
Now let's consider the role of IoT in improving security. In the domain of identification and authentication, RFID tags comprise unique identifiers people or animal could be tagged with. Since RFID systems can be used to monitor objects in real time without the need of being in line of sight, they can be used in incredibly wide range of application scenarios, spanning from logistics, healthcare, and security. Examples of these include to control access to secure areas or rooms, Ensure correct dosage is given to patients to avoid thefts or losses of important objects. The other domain is assisted driving. You can equip cars, trains, buses, roads, and rails with sensors, actuators, and processing power. Examples are you can provide important information to drivers and passengers for better navigation and safety, collision avoidance, and monitoring of transport of hazardous materials.
But is IoT itself secure? Turns out, before we can employ IoT solutions, there are several privacy, safety, and security challenges that need to be addressed. The US NIC said if everyday objects become information security risks, the IoT could distribute those risks far more widely than the internet has to date. There are various security issues to address to achieve a trusted and fault tolerant IoT. It is important to understand that people will resist the IoT until there is public confidence that it will not cause serious privacy threats. I'll give you an example. All the talking and complaints following the announcement by an Italian retailer by the name of Benetton on the plan to tag a complete line of clothes around 15 million RFID tags was the first clear confirmation of this mistrust towards the use that will be done of the data collected by IoT technologies. For the realization and adoption of the complete IoT paradigm, security and privacy are crucial factors. Secure computing and storage resourcing is essential. We can conclude it is clear that a system cannot be viable if it is not secure and if it does not maintain privacy. It is essential to know what the security and privacy challenges in IoT are.
What exactly are these concerns? The deployment of automatic communication of objects in our lives represents a danger for our future. Embedded RFID tags in our personal devices, clothes, and groceries can unknowingly be triggered to reply with their ID and other information. There is a possibility of abuse of information.
How should these be addressed then? Without strong security foundations, attacks and malfunctions in IoT will outweigh any of its benefits. This is crucial. The IoT middleware must include functions related to management of trust, privacy, and security of all the exchange data. These functions should not affect system performance or introduce excessive overheads. These functions may be either built on one specific layer or more commonly distributed through the entire stack, from the object abstraction to the service composition. Privacy should be protected by ensuring that individuals can control which of their personal data is being collected, who is collecting such data, when the data is being collected, and personal data collected should be used only to support authorized services by authorized service providers. Data should be stored only until it is strictly needed.
The Director of Technology for IoT at ARM said, without trust and security built into IoT technology and systems in a holistic way, we will not see an Internet of Things, but continue to see silos of things. This basically means things operating in isolation than others is against the IoT vision of connecting devices to each other.
In 1999, Scott McNealy said, "You have zero privacy anyway. Get over it." The Presidential Innovation Fellow founder at IPSO Alliance responded, "We should not get over it, but instead deal with it. It is critical that we think about it, experiment with it, and work to get out in front of the issues rather than play catch up."
Privacy and digital forgetting. IoT represents an environment in which privacy of individuals is seriously menaced in several ways. Private information of a person can be collected without the person being aware. Privacy problems arise for both users and non-users. While in traditional internet, problems of privacy arise mostly for internet users, in the IoT scenario, privacy problems arise even for people not using IoT services. It will be impossible to personally control the disclosure of personal information. People's concerns about privacy are indeed well justified. Digital forgetting. All the information collected about the users of the IoT system may be retained indefinitely as the cost of storage decreases. The solutions for these are to restrict networks' ability to gather data at a detailed level, privacy broker systems, remove unique identifiers, standardization, and using K anonymity. Evaluation. Remembering forever in the context of IoT raises many privacy issues as the data collected can be used in negative ways. Digital forgetting could emerge as one of the key areas of research to address the concerns and development of appropriate framework to protect personal data.
So, it seems to me that security in IoT is a major concern. I would love to know about it in detail.
Great, let's dig deeper. We will now put security in focus. I hereby warn you, after telling you about the security threats involved in the IoT, you might wonder, is this the Internet of Things or Internet of Insecure Things?
So, why focus on security? All interactions of the interconnected objects with each other as well as with human beings must be secured. All information should be protected. Limit the number of incidents that affect the entire IoT. One of the major challenges that must be overcome in order to push the Internet of Things into the real world is security. Much work needs to be done in regards to security. IoT is inherently complex. Multiple heterogeneous entities located in different contexts can exchange information with each other. This further complicates the design and deployment of efficient, interoperable, and scalable security mechanisms. IoT has a highly distributed nature and uses fragile technologies in public areas, and this creates weak links that malicious entities can exploit. Easily accessible objects in protected zones are vulnerable to physical harm.
So, why does IoT have security issues anyway? In a world of billions of things, think about it. How can we protect the communications, manage authentication and access control, maintain privacy of the users, and secure the data generated by all the things? It is important to understand that protecting IoT is a complex and difficult task. It is important to know that security will be a major concern wherever networks are deployed at a large scale. That's obvious. Avenues for malicious attacks in the case of IoT will definitely increase. Some of the examples include disabling the network availability, pushing erroneous data into the network, accessing personal information, and even physical attacks. All the three physical components of IoT, RFID, WSN, and the cloud, as mentioned earlier, are all vulnerable to such attacks.
So, what are security threats? The security threats are as follows: denial of service. Beyond traditional internet, DOS attacks that exhaust service provider resources and network bandwidth, the actual wireless communication infrastructure of most data acquisition networks can also be targeted. Physical damage. In this attacker model, active attackers usually lack technical knowledge and can only hinder the provisioning of IoT services by destroying the actual things. This is a realistic attack in the IoT context because things can be easily accessible to everyone. Eavesdropping. Passive attackers can target various communication channels in order to extract data from the information flow. An internal attacker that gains access to particular infrastructure will be able to extract the information that circulates within the infrastructure. Node capture. Instead of destroying the things, an active attacker can try to extract the information they contain. Instead of things, active attackers can also target other infrastructures that store information, such as data processing or data storage entities. Controlling. As long as there is an attack path, active attackers can try to gain partial or full control over an IoT entity. The scope of damage caused by these attacks depend mainly on the importance of data managed by that particular entity and the services that are provided by the particular entity.
I need to read this. This example extends from the security threats just mentioned. Here, notice in the center, you have a device, network, and server. These comprise the IoT system. On the left, here we demonstrate that an eavesdropper can easily listen on data or commands that can reveal confidential information about the operation of the IoT infrastructure. On the top right, we have a fake server. This can send incorrect commands and can be used to trigger unplanned events, to send some physical resource, for example, water or electricity, to an unplanned destination. And this can be very dangerous. We can even have a fake device, and this fake device can inject like fake or bogus measurements and can disrupt the control processes and cause them to react inappropriately or even dangerously, or can be used to mask even more severe physical attacks.
We just mentioned some security threats, and let's look at some solutions. The aim here is to prevent the growth of ingenious, malicious models, or at least to mitigate their impact. Keep in mind the following challenges when we look at the solutions next. Most of the IoT components are categorized by low capabilities in terms of both energy and computing resources, especially passive components. These cannot be implemented because of complex schemes supporting security. Billions of more devices will be producing and consuming services. IoT systems will be more susceptible to attack than the current internet.
For each of the next few solutions that we present, we will first discuss which problem domain they refer to, and then we will also evaluate the solutions. So let's get started. Fault tolerance. Highly constrained devices will be most vulnerable in the IoT. Malicious entities will indeed seek to control devices either directly or indirectly. Thus, fault tolerance is essential to assure service reliability. Solutions. We need to strive for security by default. We need to have robust implementations, usable systems, etc. Need to develop awareness mechanisms that can be used to create the foundations of intrusion detection and prevention mechanisms. These will help IoT entities to protect or even gracefully degrade their services when necessary. Recovery services must be able to locate unsafe zones, that is, zones affected by attacks automatically, then redirect the functionality of the systems to other trusted zones. Evaluations. Many of these approaches are being researched but have not yet been implemented. The challenge is that any solution must be specialized as well as lightweight at the same time because the devices involved in the IoT are constrained and easily accessible.
Authentication and authorization. Without authentication, it will not be possible to assure that the data flow produced by a certain entity contains what it is supposed to contain. Without authorization, everything will be accessed by everyone, which is neither viable nor realistic. Solutions. Device ID certificates issued to each device at the point of manufacturing to establish identity can be implemented. Sensor nodes must be seen as nodes of internet so that it becomes necessary to authenticate them even from the nodes not belonging to the same network. Periodically, new sensor applications need to be installed or existing ones need to be updated. This can be done by remote wireless reprogramming of all nodes in the network. A secure reprogramming protocol, such as Deluge, can be used to allow the nodes to authenticate every code update and prevent malicious installation. Evaluation. In the last few years, some solutions have been proposed for the RFID systems. However, they all have serious problems. None of the existing solutions can help in solving the proxy attack problem, also known as the man-in-the-middle attack. We need cryptographic add-ons to Deluge. This is a problem because such algorithms spend large amounts of resources like energy and bandwidth, both at the source and destination. Such solutions cannot be applied to IoT, as there is a need for more sophisticated lightweight algorithms.
Communications. As messages are communicated, messages and data could be intercepted, captured, or manipulated while in transit. We mentioned before, eavesdropping is like the monitoring of messages, and we also demonstrated message falsification, the altering of messages. The data involved in IoT can be sensitive. Such attacks can indeed be dangerous and can jeopardize the trust in the information and data being transmitted, and the ultimate confidence eventually in the overall infrastructure. The solutions proposed include the data in the cloud and the IoT environment should be encrypted to prevent interception and to maintain data confidentiality. The stored data should be transparently and seamlessly encrypted to prevent theft. Secure communication capabilities are needed. The most secure communication protocols, TLS or DTLS, actually work by first authenticating the communicating parties, then they create a session key that protects the confidentiality and the integrity of messages between the parties. Evaluations. Assigning a unique identification key and certificate to each device indeed does increase security, but it is important to know that it also adds a layer of complexity. That is actually why, in the first place, that less secure protocols skip this encryption step to improve their performance. Indeed, there is a need to reduce this added complexity of key management for IoT communications to be indeed secure.
Data integrity. Devices spend most of the time unattended. Data can be modified by adversaries while it is stored in the node or when it traverses the network. Data integrity is usually ensured by protecting data with passwords. But then, often the password lengths supported by IoT technologies are too short to provide strong levels of protection. And the solutions are, there is a need to guarantee that an adversary cannot modify data in the transaction without the system detecting the change. Memory is protected in most tag technologies, and solutions have been proposed for wireless sensor networks as well. For example, EPC Global Class 1 Generation 2 have 5 areas of memory, and each of which can be protected in read or write operations with a password independent of each other. Messages can be protected according to the key hash message authentication code scheme. Based on a common secret key shared between the tag and the destination of a message, it can be used in combination with the hash function to provide authentication. Evaluation. Even if solutions support longer passwords, still the management remains a challenging task, especially when entities belong to different organizations, as in the case of IoT, are involved.
Protocol and network security. Constrained devices will interact with various heterogeneous devices, other constrained devices, full-fledged web servers, and so on, be it directly or through gateways. There is a need to adapt or create lightweight security protocols that offer an end-to-end secure communication channel. Solutions. These security protocols just mentioned require credentials, obviously. Optimal key management systems must be implemented to distribute these credentials. This is done in order to help in establishing the necessary session keys between peers. 6LoWPAN and CoAP progress towards reducing the gap between internet protocols and the IoT. Evaluation. 6LoWPAN and CoAP do not target protocol specifications that are identical to their internet pendants due to performance reasons. Hence, subtle differences between the IoT protocols and internet protocols will continue to remain. These differences can easily be bridged with protocol translators at gateways, but they become major obstacles if end-to-end security measures between IoT devices and the internet hosts are used.
Thanks. Wow, that is a lot of information you got there. Would you be nice enough to summarize it for me? Please. Pretty please?
Of course. Let's wrap it up.
Future directions. Several significant obstacles continue to remain to fulfill the IoT vision, security being the chief among them. The standards and security mechanisms presented here are indeed good first steps, but much additional work is required to build a robust and secure IoT. Security in the cloud is another important area of research which will definitely need more attention. Along with the presence of the data and tools, the cloud also handles the economics of IoT, which will make it a bigger threat from attackers. Security and identity protection indeed becomes critical in hybrid clouds, where private as well as public clouds will be used by businesses.
Now let's sum it all up. The main goal of this presentation was to provide an overview of the security, privacy, and safety concerns particular to the IoT context in order to understand its place in the future internet. In a nutshell, in the vision of IoT, extreme interconnections will surely bring unprecedented convenience and economic development. But it will also require novel approaches to ensure its safe and ethical use. To avoid security threats mentioned, strong security foundations must be built on a holistic view of security for all IoT elements at all stages, from object identification to service provision, from data acquisition to infrastructure governance. All security mechanisms must consider each object's life cycle and services from the very beginning. The IoT comprises elements that are seriously constrained in terms of energy, communications, and computation capabilities. It is desired to have new solutions able to provide a satisfactory level of security regardless of the scarcity of resources. The designs of specific security IoT mechanisms are still in their infancy, but recent developments are encouraging and could provide some degree of protection to existing IoT applications. Owing to the nature of the huge number of data providers, the things being realistic, it is clear that any IoT application will have to deal with a certain amount of bogus data.
To conclude, the Presidential Innovation Fellow Founder at the IPSO Alliance said, "The next generation of devices that will become part of the Internet of Things will not just sense and report, but they will control. The protection of the control data and operating instructions will be critical as we allow greater control and autonomy so as to ensure our safety and security. Privacy and security by design is imperative and must not be an afterthought."